Welcome. Okay, we're doing different base systems in this video. Okay, so the goal is to understand like what different bases are. So it is most of the time going to be helpful when thinking about other bases to compare to our current like base 10 system, which we normally use. So our base 10 system, if I write 2,345, like implicitly, like, I kind of understand intuitively like what this number means. I know how to use it and stuff like that, but I don't really think too much about like what all of the digits mean all that often. I just kind of take it for granted, as most people do. But what it really means, so what it really means is the following. So each of the digits is a placeholder, or it's a value like that corresponds to a place value. So this, like, the 5 is like the ones place, the 4 is the tens place, 3 is the hundreds place, the 2 is the thousands place. So this really means 2 groups of 1,000, 3 groups of 100, 4 groups of 10, 5 groups of 1, and then we just sort of combine them together. Okay. All right. Okay. So also there's this like sort of notation thing right here. So sometimes when it is not clear necessarily what base we are discussing a number in, we'll put like a little subscript and we'll write in letters what base we are in. Oh, yeah, sorry. Yeah, this is just kind of what I said out loud. 2 groups of 1,000. Oh, by the way, it's good to kind of keep in mind 1,000 is the same as like 10 cubed. 100 is the same as like 10 squared. And so like every time you go up a place value, you're like just multiplying by another 10. So like your place values are like 10 to the 0, which is equal to 1, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, and so on. Okay, so on to different bases. What is a base 6 number? Like, what does it mean to be working in base 6? So if I were to write down something like this, 5, 4, 3, 2, base 6, what does this really mean? So it's the same as like back when we were doing base 10, except instead of using groups of 10, and our place values increase by like multiplying by 10 every time, we're just going to do that with groups of 6 and powers of 6. So this it's probably more helpful to think of this going right to left. So this means 2 groups of 1, 3 groups of 6, 4 groups of 6 squared, and then 5 groups of 6 cubed. Right, and if this was like 1, 2, 3, 4, 5, something like that, like if I had like an extra like 5 place values, this one right here would be like one group of 6 to the 4th, which I don't know what 6 to the 4th is off the top of my head, but that's what it would be. Okay. Counting. What does counting look like? So we're going to count in base 4, see what that kind of looks like. So in base 10, before we count in base 4, let's think about like what happens when we count in base 10. Like, just imagine you're trying to teach counting in base 10 to a kid. So obviously, like if they're just saying the words, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like they'll just understand that like 9 comes after 8, 10 comes after 9. After that, 10 comes after 9, 11 comes after 10, 12 comes, so on and so forth, right? But in symbols, that's actually a little bit more confusing because of how we write the digits. So like we do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then instead of having just like another symbol for like the number that comes after it, we write it like this, like a 1 and then a 0. And then we write a 1 and then a 1, and then a 1 and then a 2. And this is because we're making groups of 10 here. So we don't want to have like infinite number of digits to correspond to like each digit like gets assigned to a number. It just makes more sense to have it like, oh, this is like one group of 10 and then 0 groups of 1. And then this is one group of 10 and then one group of 1, and so on. So every time that we can make a group of 10 in our base 10 system, we turn whatever that 9 is, we like combine that into like one group of like the next highest place value. And so like way down the line, when we get to like 999, then once you count up from there, like this 9 would group to that 1 to become like a 10. And then, oh, hey, now you have 110 combined with this 9. Those get grouped into a 10. And then, oh, hey, you have this 1 that combines with this 9. That turns into a 10. And so you end up having like a 1 and then 3 zeros in it, which is kind of confusing to even like kind of explain for me personally. But, you know, intuitively, this all makes sense to us. So let's do the same thing in base 4. So we'll start at 0 and then count to 1 and then 2 and then 3. And then once we get to a group of 4, because remember in base 4, like we would want to write 4 as 1, 0 base 4, because 1, 0 base 4 would mean one group of 4 and 0 groups of 1, right? So one group of 4, that's 4. So right here, I would write 10 base 4. Technically, all of these numbers I should be writing base 4 at as a subscript. It doesn't really matter for the one-digit numbers, but I digress. Okay, after 1, 0 base 4 comes 1, 1 base 4. I don't know why I'm writing plus. Should be putting commas. And then 1, 2 base 4. 1, 3 base 4. And then instead of writing 1, 4 base 4, I can make a group of 4 and increase my 4's place by 1. So this would be 2, 0 base 4. And then I'll have 2, 1. I'm going to stop writing the subscript. 2, 1, 2, 2, 2, 3. And then instead of 2, 4, I put 3, 0, 3, 1, 3, 2, 3, 3. And then instead of writing 3, 4, I would think to then write, 4, 0, but instead of writing 4, 0, I actually write 1, 0, 0. Oops. So that's kind of like the 100 base 4, if that makes sense. So we try not to like say 100 base 4 here. We try to just say the digits, like 100 base 4, just because it's less ambiguous that way what you mean by 100 base 4. Like if I say 100 base 4, I might sometimes mean like 100 like base 10, but then convert it into base 4. Whereas like 100 base 4 thought of in base 10, like those are different concepts. So it's confusing. So just say like the digits and then the base. Okay, so anyway, if you understand that, great. Maybe try and list the first like 40 numbers or so in base 6. See if you can count up that high. So I'll give you like a couple seconds to pause and then we can go over. All right. So depending on like whether you start at 1 or 0, it's gonna like technically change like how high you count. So let's just we'll count 0, 1, 2, 3, 4, 5. And then after that, I would write 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. And I'm going to organize them this way just so I can say like, oh, these are just like groups of 6, right? Then I can just count them easier. After 1, 5, I can make another group of 6. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So far I have 18 numbers. And then I would do 3, 0. Oh, I messed up. Sorry. 2, 6 does not make sense. I forgot to write 2, 0. So after 1, 5 comes 2, 0 base 6. Because after I make a group of 6, I would make two groups of 6 and then 0 groups of 1 and then 2 groups of 6, 1 group of 1, so on and so forth. And then instead of writing 2, 6, I've made a group of 6, and then I'm going to group that with the other group of 6 right there to make a 3, 0 base 6. This goes up to 3, 5, and then 4, 0. Okay, how many do we have? 6, 12, 18, 24, 30. And then after here, this is when you would write your 1, 0, 0 base 6. Technically, all of these things should be like with a subscript of 6 right there. But whatever. Show that we're at like 37 right now. So let's just finish this row. Okay. Cool. Yeah, and if I were to specifically count like the first like 40, you could just kind of stop at like whatever 40 is over here. Okay, anyway. Note that the only digits that we use in base 6 were the digits 0 through 5. So if I were to write something like 2, 1, 5, 6 base 6, like this doesn't make sense. 2, 1, 5, 6 base 6, like yeah, technically you could make sense of it, but it's like if in our base 10 system, if we were to write 2, 5, and then like 10 groups of 10 and then 7, like this would, like if we just like treated 10 as like a digit right there, like it wouldn't make sense. It would be like if you used 10 as a digit for like your tens place or for your hundreds place or for your thousands place. Like it just doesn't make sense to do that. So don't ever write this. Like if you're in like base 6, don't use any digit that is 6 or larger. If you're in base 4, don't use any digit that is 4 or larger. Only use the digits 0 through 1 less than what your base is. So if you're doing like binary is like base 2, your only digits would be 0s and 1s. If you're not already familiar with binary, that's like basically the language that computers use. Like they only use, like they interpret like everything in terms of binary, pretty much. Okay. Converting numbers to base 10. So we already kind of talked about how to do it. So in terms of converting to base 10, like really just think about like what this number means. It is equal to like one group of 4 to the something, 0 groups of 4 to the something. This would be 4 to the 2. This would be 4 to the 3. And then 2 groups of 4 to the 1. And then 3 groups of 1. Okay, so yeah, we have, this is our 1's place, 4's place, 4 squared's place, 4 cubed place. So that's what this number represents. So if I want to convert this to base 10, basically, like we've already converted it to base 10 right here. Like we started using base 10 digits once we started writing this. And so if I wanted to like compute what this is, okay, 4 cubed is equal to what? 4, 16, 64. So this is equal to 64. Obviously that's 0. This is 8. This is 3. And like immediately, like we are no longer thinking of these numbers as base 4 numbers. Like we're just right off the bat just converting these into base 10, like a sum and product of base 10 numbers. So 64 plus 8 8 is 72, plus 3 is 75. So this in base 10 is equal to 75. All right, let's see. Yeah, I'll let you try this one. Convert 153 base 8 into base 10. See if you're able to do that. Yeah, I'm going to assume you paused and gave it a shot. This would be one group of 8 squared plus 5 groups of 8 plus 3 groups of 1. So this is 64, and this is 40. This is 3. So this is 107, if I add that correctly. 60, yeah, that's 104, 107. Okay, so this would be 107 base 10. If you want to put the little 10 subscript just to make it clear that that's in base 10, go ahead. A lot of times, like if we leave off the subscript, generally speaking, you can just assume that it's being interpreted as a base 10 number. Okay, base 12. So our different bases don't just have to be in bases that are like smaller than 10, like where we sort of cut off our digits. So like in base 6, we cut off our digits at 5. We use the digits 0, 1, 2, 3, 4, 5 in a base 6 system. We're cutting off like the other digits that we regularly use. But what about in base 12? So in base 12, like you're supposed to have groups of 12. So you only like go up a place value once you make a group of 12. So if you're counting like the first like 13 base 12 numbers, you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can't write this because what would come after this? So like once you get to a group of 12, in base 12, you should be writing that as 1, 0 base 12, right? So I can't write 1, 0 to mean 10 here anymore. This just doesn't make sense because we're already like 1, 0 in base 12 already means something. And again, technically all of these things have to have like that subscript. Like, okay, sure, you could make this be like technically like 1, 0 base 10, but then, you know, you're mixing and matching like different base systems. And then what happens once you get up to like 18 base 12 and then, or sorry, 1, 8 base 12 and then 1, 9 base 12. And then what comes after that? You need another digit. And that digit that we're going to use, we're just going to use letters because why not? So we'll use the letter A to represent 10 and the letter B to represent 12. To represent 11. A represents 10, B represents 11. And so after 1, 8 base 12, we have 1, 9 base 12, and then 1A base 12, 1B base 12, and then here we have like 11 groups of 1, and then the next one we would count up to would be 2, 0 base 12. So those are our digits, just 0 through 9, and then we include the letters A and B. All right, so let's convert something in base 12 into base 10. So it's going to be really similar. So 2BA base 12 just means 2 groups of 12 squared plus B, which represents 11, groups of 12 plus A, which represents 10 groups of 1. Okay. I could sometimes instead of writing 11 and 10 in my first step, I might actually just literally write B and then A, and then in my second step I would go back to like writing this as 11 and then 10. But again, from earlier, like the point is to write all of these things as base 10 numbers, like this right here, 12. This is a base 10 actual 12, right? Okay, so 12 squared is 144. 11 times 12 is 132. 2 times 144 is 288. 132 plus 10 is 142. And if I were to combine these three numbers, or sorry, these two numbers, let's see, 2 and the 8 makes it 10. 28 plus 42, sorry, 28 plus 14 is 42, so this should be 430, if I'm doing that right. Yeah, I think that's right. Okay. Cool. Hexadecimal is another very common base that gets used. So hexadecimal is just base 16. So in here, the digits that we're going to use are, again, going to be like 0 through 9, and then we'll have A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. So our digits stop at 15, one short of 16, just as we've kind of been doing. And yeah, so those are the digits. So let's convert 2FA base 16 into base 10. I think this is probably a good chance for you, again, to get some practice. So pause the video, try to convert this to base 10, and then come back, compare answers. All right. So 2 is in the 16 squared place value. F is, I'm just going to write F in the 16 place value, and then A groups of 1. All right, and then 16 squared is 256. What does F represent? So if you need to kind of go through it in your head, you can always just count like A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. Okay, so this is 15 times 16. Right. Did I do that right? Yeah, F is 15. Okay. And then A is just 10. So 2 times 256 is 512. 15 times 16. Let's see, this is the same as like 15 times 4 times 4. So that's 60 times 4. So that should be 240. And then plus 10. So this is 512 plus 250, which is equal to 762, base 10. All right. So that's enough of converting to base 10. Let's do the reverse. So the reverse is start with something that is already in base 10 and then write it as a base 6 or base 4 or base 2, whatever base number. Okay, so how do I convert 234 base 10 into base 6? So remember that in base 6, we would have like a bunch of place values. So we would have our 1's place, we would have our 6 place, we would have our 6 squared or 36 place, we would have like 216 place. So this is like 6 to the 3rd, 6 squared. Then our next place value would be whatever 6 to the 4th is, and so on. And so if we wanted to take 234 and then convert this into a number where we have some number of groups of this size, some number of groups of 216, some number of groups of 36, some number of groups of 6, some number of groups of 1, what could we do? So we can so what we do is look for the biggest place value first. So what would be like the biggest place value that would not be 0? Like, would it be 6 to the 4th, which would be like, I don't know what that number is, but like 6 times 200, like this is going to be like at least 1,200, right? It's going to be bigger than that number, right? So would this have like a place value of 1 or bigger? Well, no, because if it did, then like this whole number overall, even this was like 1000, this number would still be bigger than like 1,200, and this number is considerably smaller than 1,200. So this is a 0. And then 216, that's actually smaller than 234. So we can actually get some number of groups of 216 out of like 234. How many groups of 216 go into 234? Well, in this case, it's easy to just see that it's just going to be 1. There's one group of 216 that goes into 234. So let's take that away. So 234 minus 216, what's going to be left? That would be 18. Okay, so we've taken one group of 216 away from 234, and we're left with 18. Okay, well, what's like the next largest place value? Well, how many groups of 36 go into 18? Well, none. 36 is much bigger than 18. How many groups of 6 go into 18? Well, 3. 18 divided by 6 is equal to 3. And it actually goes in evenly. So if I were to do just take away 6 3 times, then I'm left with nothing left over. If I'm left with nothing left over, then any further place values to the right are just going to be zeros. Okay. So our final answer is that 234 base 10 is equal to 1030 base 6. You could always check your answer from this. So if you're comfortable with converting from base 6 to base 10, base 6 to base 10, this would be one group of 6 to the third plus 0 groups of 6 squared plus 3 groups of 6 plus 0 groups of 1. If you add those together, this would be 216 plus 0 plus 18 plus 0, which is indeed equal to 234, which is the number that we started with. So it's just a good way to check your work. But indeed, 1030 was our answer. All right, let's convert 300 to base 4. So if you were comfortable with what happened on the previous video, feel free to pause and just try this on your own. If not, feel free to just sit back and listen. So, all right, let's put down our place values. So our place values for base 4 would be 1, 4, 4 squared, which is 16, 4 to the third, which would be 64, and then will be the next biggest one, be like 256. Next biggest one would be 1024. And at this point, like once this number becomes bigger than the number that we're converting into base 4, then we can just stop. Like I could have stopped right here, because like in my head I knew that this number was going to be way too big, because 256 is like only a little bit smaller than 300. If I were to multiply this by 4, I'm going to get a number bigger than 300, right? Okay, so how many groups of 256 go into 300? Hopefully you can see that just one. If I were to do 2 groups of 256, that'd be like over 500. It's not going to work. All right, so let's take 256 away from 300. We're going to be left with 44. All right. Do any groups of 64 go into that? No, 64 is too big. Any groups of 16 go into 44? Yeah, 16 goes into 44 twice. So at this point, you could do this with like long division. Just say like, oh, 64 or 16 goes into 44 twice. So 32. What are we left with? We're left with 12. So 12 is our remainder. We'll put a 2 right there to say we have 2 groups of 16 and then 12 left over. If we have 12 left over, how many groups of 4 are going to go into that? Well, that would be 3 groups of 4, and then we won't have any ones left over. If this was like 303 base 4, then all of a sudden this would be like a 3 now. Let's just keep it as the original problem though, and so this would be basically our answer. We would have 10. Let's write it a little bit cleaner. 10230 base 4 for our final answer. All right, let's convert to base 12. So base 12, it's going to be the same ideas. We just kind of have to keep in mind like what's going on with the digits a little bit more. Ooh. All right, so what are our place values for base 12? So 1, 12, 144, and then something that's going to be too big. So this would be like 12 to the third. 12 to the third is going to be much larger. I don't know what it is, but it's going to be bigger than 563. Right? Okay, so how many groups of 144 are going to go into 563? I'm going to do this with long division again. 144, and let's see what our remainder is. So it looks like it's only going to go in 3 times, because this is like about 150, right? So 150 times 3 is going to be about 450, and 150 times 4 would be like about 600. So I would expect that this would probably work. All right, 144 times 3 is equal to, well, if I wanted to actually just multiply it out, just put it over here. 4 times 3 is 12. 12 plus another 1 is 13. And then 1 times 3 plus 4, so 432. Okay, subtract that. Get 131. Okay, and so this number is smaller than 144, so that tells me that I did this right. Like, let me in red do what you might do sometimes. So like let's say that you for some reason thought that the quotient would be 2. Then you do 288 and then subtract that. Let's see if it's 5, 13, 5. So 4, 15, 7. So 275. Okay, so you get 275 as your remainder. 275 is actually bigger than 144, so that means that you could have taken away an extra 1 from your original, right? So this tells you like, oh, because this number is bigger than that, then you should have taken away more when you did that quotient. All right, let's get rid of that. So we have 3 groups of 144, and then we have 131 left. Okay, how many groups of 12 go into 130? Well, if you do 10 groups of 12, if you do, okay, yeah, you just do it this way. So 1 times 12 is just 12. Then you have 1 left over. How many times does 12 go into 11? 0 times. And so you get just a remainder of 11. So you can put a 10 right here. Okay, something that I just wrote on the screen is wrong. Did you catch what I did wrong here? Or not necessarily wrong, but like, you know, something we should probably not do. So what we should probably not do at this point is write 10 right here, okay? Because again, we're trying to convert to base 12, so we want to use base 12 digits. So instead of using that, we should just use the letter A to represent our, I'll do it in blue to indicate it's correct, to have this as a base 12 digit or a base 12 number or whatever. Okay, cool. And then we have 11 left over. So I could write 11 groups of 1 right here, but again, it's probably better to write this in terms of base 12 digits. So that would be the letter B, or the digit B, I guess, in this case. So 563 base 10 converted to base 12 would be equal to 3AB base 12. All right, enough of that. Let's next talk about converting between weird bases. So like, how might we convert something like 123 base 4 into something like base 6, for example, right? So one thing that you could do, one strategy you could take, is convert to base 10. We've already discussed how to convert base 4 into base 10. And then once you get a base 10 number, then we've already discussed how do you take a base 10 number and convert it into base 6. So what would that look like here? Well, 123 base 4, that's equal to 1 group of 4 squared plus 2 groups of 4 plus 3 groups of 1. So this is 16 plus 8 plus 3, which is equal to 27. All right, well, what is 27 in base 6? Well, what are my place values? 1, 6, 36, and so on. So 36 is too big. We can have 4 groups of 6. That would give us 24, and then we'd have 3 left over. So this would be equal to 4, 3, base 6. Okay. If I did that a little bit too fast for you, don't worry. Just kind of think about it like big picture of we start with 1, 2, 3, base 4. We convert to a base 10 number like we did right here. And then once we get that base 10 number, then you do like the same tricks we were doing in like the earlier slides to convert it to a base 6 number. Okay. We're not going to be doing a ton of that because that's like, it's a 2-step process. I'll usually just, ask you to do 1 step for 1 problem and then just kind of split it up into like different types of questions, All right, last thing. I think this is kind of dumb, but it's in the homework. And because there's a homework problem on it, I'm obligated to cover it. But I think it's dumb. It's called the double dabble method. It's just a weird way to convert from base 2 to base 10. We've already discussed a way to convert from base 2 to base 10, but double dabble is like another method that you could do. Okay, anyway, here are the rules. So you take a number in base 2, and then you're going to scan the number left to right. Every time you pass a 0, you double your number. Every time you pass a 1, you double your number and add 1, which is called dabbling. So this is called doubling. This is called dabbling, I guess. Okay. So if we wanted to convert 1100101 base 2 into base 10, so you could just do like the thing of like, place value. This is the 1's place, 2's place, 4's place, 8, 16, 32, 64, and add things all up that way. So you'd have 64 plus 32 plus 0 plus 0 plus 4 plus 1 if you were to just count it that way, which would be equal to 96 plus 4. Wait. Yeah, I think that's 101. Yeah, okay. So you get 101. Or you could do the double dabble method. So the double dabble method, I'm going to write it over here. I'm going to spread the digits out a little bit just to sort of demonstrate. So at this point, we pass the number 1. Okay, I should, not think of it like that. So we start right here. We're starting with a 1. Scanning left to right, we then get to a 1. So if we have a 1 at this point, and then we scan, and then we find a 1, then we dabble. That means we double and add 1. So if I take the number 1, double it, and add 1, I get 3. Okay, next number I get is 0. I'm passing a 0, I double. What do I get when I double 3? I get 6. I get to another 0. I double again. I get to a 1. That means I dabble. What is 12 times 2 plus 1? I double and then add 1. I get 25. I find another 0. I double it. So I am at 50. I get to a 1. That means I dabble. So I double 50 and I add 1. What's 50 doubled and adding 1? I get 101. And so that would be our final answer is 101 base 10. Okay, so maybe you think that's cute or helpful. Hopefully, if you don't, you could just stick to like the previous method. I'm not going to test you on it. It's just in there because there is a homework problem on it anyway. Yeah, so anyway, hope you enjoyed. Hope you learned something. And I will see you in the next video. Have a good night.